Hey everybody, in this video we are looking at example number 13 on the Pre-Calculus Final Exam Review playlist. The question is asking us what are the coordinates of the whole for the function f of x equals x squared minus 36 all over x squared minus 7x plus 6. I will first just answer the question and then I will probably get carried away and graph the whole thing for anyone who is curious about the full graph. So if you are just being asked like a multiple choice question perhaps to find the coordinates of the whole, like in the last two videos, I will attach the instructions on how to graph a rational function in the description, as well as in a thumbnail at the end of this video. To get the whole, one thing that we do want to make sure we are doing is we want to make sure that we are factoring everything. So f of x equals, the numerator is x plus 6 and x minus 6 because that is the difference of two squares. The denominator is 6 and 1 are going to multiply for 6 to get 7, negative 7, both negative. This is plus, that means both signs are the same and they both are whatever that sign is. They're both minus, so x minus 6 and x minus 1. Then anytime you have a common factor in the numerator and denominator, we can then, from there, we can remove the common factor. That is the removable discontinuity. That represents a whole, and I like to think when I'm crossing that out, I am spackling that whole, and then the function that is left behind is the x, not what I wanted. The function left behind is x plus 6 over x minus 1. This is the drawing that you're putting the whole into. Now, when is our whole happening? When x equals 6, right? So x minus 6 equals 0. When x equals 6 is the whole x value. But you need an ordered pair. So how do you find the coordinate? 6 comma what? How do we figure that out? The way you figure it out is you take 6 and you fill in 6 for x. What do I get? 6 plus 6 over 6 minus 1. 12 over 5, and that is equal to 2 and 2/5, which is 2 and 4/5, which is 2.4. So I'm just going to do that because when I draw it in a moment, you know, you're going to want to see the coordinate point of the whole, maybe as a decimal, it will be more helpful. Okay, so that right there is done. Think about what I just did. I just kind of talked you through it. Listen to it again if you're curious of the entire graph. Again, this is equal to x plus 6, x minus 1. So my graph, let's see here, 1, 2, 3, 4, 5, negative 6, 7, 8, 9, 1, 2, there's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay. All right. So let's plot and plot and plot. My x-intercept comes from the numerator, setting that equal to 0. It is negative 6. It is linear because it's technically first power. My vertical asymptote is at positive 1. It is odd asymptotic behavior, so one branch will point up against it, the other branch will point down against it. Then leading term over leading term, x over x is 1. That is horizontal, a constant. That is my horizontal asymptote at positive 1 right there. And my whole, which we just found in the order pair, 6 comma 2.4. Oops, I didn't go out there. 1, 2, 3, 4, 5, 6, comma 2.4. So that's 2, that's 3. So somewhere over there is the whole. And my y-intercept, I get plug in 0 for x. 6 over negative 1 is negative 6. There's my y-intercept. And now I can draw my graph. I'm going to pass through my y-intercept. I'm going to right up against, maybe I should draw a little bit better, curve it more. So up against that asymptote, it's going to curve and go really like all the way, okay? Against the asymptote, down, 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 forever, okay? Then over here, linear behavior at that negative 6, it's going to cut on through and right against this asymptote at +1 with my end behavior. That right there is a hole, and I'm going to approach my asymptote there as well as there. So it kind of looks like the 1 over x function. In fact, if you did division, if you did, if you did division of x plus 6 over x minus 1, you would actually get this to be in the form of a transformation form. I could show you that really quickly if you want. That's a bonus treat for anyone who's interested. Here's 1, 1, 6. I'm dividing. I get 1 over here. 1 times 1 is 1. That is 7. So that means I get 1 plus 7 over x plus 6. I could take that. Oh, you can't even see it. So I'll erase it and write it somewhere else. I'm going to write it up here. 1 plus, that's my remainder 7, right? 1 plus 7 over x minus 1, which I can reverse as 7 over x minus 1 plus 1. So that means I moved right 1, boom, 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 that's where my vertical is. Up 1, la, 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 that's where my horizontal is. 7 on top, that's my vertical stretch of 7. From here I can go up 7, so I'm already at 1, I'd be like at 8-ish. Or I could go over 7 and up 1, if you remember from that unit, over 7 down 1, that's that point right there. Over 1 down 7, that's actually that point right there, yada yada. And it's now in that form, right, that we know from that unit. I made a mess circling it, but hopefully you get the gist. Here. That is the same as x plus 6 over x minus 1. But obviously we're not accounting for the whole, but that's the end of that. For the domain and range, you would have to take the whole into account. Our domain, if you needed it, would be from -infinity until 1 parenthesis, then parenthesis 1 until 6 with a parenthesis, union again, and then with a parenthesis 6 until infinity. That would be my domain. And my range from the bottom up would be -infinity until 1 with a parenthesis, parenthesis 1 until 2 with a parenthesis, and 2.4 rather, and then parenthesis after from 2.4 all the way up until infinity. So just some side information. I hope that you appreciate all of that. If you do, thumbs up. If not, if you hate it, whatever, thumbs down. Questions, comments, concerns, feedback, and requests, go in the comment section down below. Check the thumbnails on the screen right now for some suggestions, or the playlist in the description box if that is easier for you to analyze. That's it for now. Adios.